All right, today we're going to talk about chord properties mostly. So the first one is, here you can see that these two chords are the same length. If your two chords are congruent, then your two arc lengths are congruent too. So here, if this piece is congruent to this one, that also means that these two are congruent to each other. All right, and then this is just the opposite. If the two arc lengths are congruent, then their two chords are congruent also. So we're going to go ahead and write that out. Let's do smaller. If the chords are congruent, then their corresponding arc lengths are congruent. Or here, if two chords are congruent, then their corresponding arc lengths are congruent. And then this is just the opposite. If two arc lengths are congruent, then their corresponding chords are congruent. Okay, just the opposite, or the converse. All right, so find the measure of arc CF. So we're trying to find this one. Since we know these two are the same, that means this one is also 106. So you have these all figured out. So if you take 360 minus 106 twice minus 33, you know that this one is 115. Okay, on B, we know that these two are the same. Actually, all three of these are the same. So what I'm going to do is take 360 minus 108. Is 252. And then I have 3 that are all the same. So if I divide that by 3, then they're all 84. All 3 of these are 84. All right, find x. We know that these are the same, which means, let me highlight here. This piece is the same as this piece. So if this all the way across is 12, this all the way across is 12. And so x is 10. All right, so next theorem. This is a different theorem here. We're saying that if the diameter, if the diameter is perpendicular to a chord, then the chord and their arcs are bisected. So what that means here, if this diameter is perpendicular, this chord is bisected, and then the arc lengths, similarly as before, are bisected, they'd be congruent. So then this is just the opposite. If we don't know it goes through the center, we call it a secant line. If the secant bisects a chord, then it must be the diameter. Okay, so if this happens, then we know that this one must go through the center. If this didn't happen, it might be a little bit right or left. All right, so find x. We know that this is bisected, so these are both 5. So you have a leg here of 5, and you're trying to find this leg, and the hypotenuse is 13. So if you use your Pythagorean theorem, we know that this leg is 12. Okay, that's a triple. That might be one you know. Otherwise, you could do 5 squared plus b squared equals 13 squared. But this does come out for b to be 12. Okay, that means all the way across, the whole diameter. Since this little piece is 1, the whole diameter is 13. So the radius is what x is. Your radius is 6.5. All right, find x. Since this is perpendicular, it is bisected, which means this piece is 5. So I'll need to use Pythagorean theorem so I can find my hypotenuse here. And this is not a triple, so I'm going to go ahead and work it out. You have 4 squared plus 5 squared equals c squared. Okay, and it says 2 decimal places. Remember, they typically tell us if they want exact or rounded form. So this would be 6.40. All right, here we are trying to find a radius. Now this radius, I'm going to redraw to be in here because my radius can be moved anywhere around my circle. And if I have 3, 4, this is another triple, so x must be 5. Okay, 3, 4, 5 is a triple, 5, 12, 13 is a triple. They appear a lot, but again, if you weren't sure, you can do 3 squared plus 4 squared equals c squared. Okay, that does give you 5 equals c when you finish filling it out. Okay, next page. Last theorem we're talking about today says if 2 chords are equidistant from the center, which just means they're the same distance from the middle, then they are congruent. Okay, so we're saying that these 2 chords, CD, is congruent to AB. Okay, and then very similarly, but just the opposite, the converse, if 2 chords are congruent, then they are equidistant from the center, meaning that they're the same distance away from the middle. So if you know that these chords are congruent, then you know they're the same distance from the middle. All right, so using this, these 2 chords are the same distance away. So this is just half of it, so the whole thing would be 13, which makes this whole thing 13. Okay, here we know that these 2 are the same distance from the center, meaning this chord and this chord are the same. So if this was 8 all the way across, then this is also 8 all the way across, but I'm going to go ahead and leave it like that, which would make this 4 also, since they're saying these 2 are the same. So the last thing we need to find is the hypotenuse. Now I can either use Pythagorean theorem, but I also know this is a 45, 45, 90 because these 2 sides are the same, which means it'd be 4, 4, and 4 root 2. But if you didn't know that, again, you can always use your Pythagorean theorem. You're going to end up here, 32 equals c squared. The square root of 32 is 4 root 2. Okay, so that is how we find x there. On this one, we are saying that these 2 are the same. And we don't have any chords in this case except for the one they make up together. But what we do know is that since this arc length is 90, this central angle is 90, which means half of it is 45. And then you know that this is 90, so this is a 45, 45, 90 triangle again, which means it's going to be 12, 12, and 12 root 2. So your x here is 12.